To develop a nonwoven fabric for personal protective clothing against pathogens, the following should be considered: the protection barrier, the breathability, the resistance, the static. Which of these would you consider to be more important? If you do not have a reliable and effective barrier, you are putting your health at unnecessary risk. If you have an acceptable barrier but you don't have the breathability required for human use, use is impossible and performance is dramatically restricted. If there is no resistance for the moving action of the person even in the abuse that a critical situation demands, waste is produced. If there is a high level of static, microorganisms and particles that we try to avoid are attracted more intensely. It would be like wearing a bulletproof vest that attracts bullets. The big problem is that due to the nature of the materials to develop a non-woven barrier against pathogens, it must be decided what percentage of participation each of these characteristics should have. For example, the higher the breathability, the lower the barrier, or the higher the barrier, the higher the static. Reducing static is a great challenge for developers, because if it is not controlled, all other attributes are reduced. However, in the development of non-woven fabrics for furniture, bags, or countless other applications, statics and other attributes can be ignored or dispensed with. In the end, all thermobonded nonwovens will have almost the same visual appearance, which many Chinese and domestic manufacturers take advantage of to use these simple or common fabrics in so-called protective garments. With the objective of selling cheap on the main objective, which is real protection. The water test is not a good indicator. By nature, polypropylene is hydrophobic. But water is not the problem is viruses, enzymes, and other substances with much lower surface tension such as fats. The coronavirus is composed of a fat envelope, called a capsid, which protects everything. The molecules of our fibers are made up of a head that attracts water and a tail that attracts fat. Thus, the tail of the molecules of our fibers hooks onto the fatty envelope of the virus and undoes its entire structure. At Hindernis, we first look at static reduction. Subsequently, thanks to nanotechnology, we can add extraordinary additional barrier and resistance properties, and then nanostructure the fibers so that they provide excellent breathability, thus obtaining unique fabrics with surprising and extraordinary properties, created specifically for each particular purpose, exceeding all international standards. At Hindernis, we develop materials capable of comfortably safeguarding health, even during the most demanding situations for an excessive time.
When health is at risk, Hindernis, protect.
Hindernis. Exzellenz in Schutzkleidung.